not here anymore.
Intake 1.
Intake 2 now.
Yeah, intake 2.
Yeah. You're intake 1 now.
She can't imitate typical student.
No.
Days.
They're happier in this class now. They don't have any Karar, any Fahad, any KJ, any Yemi, any Tekken. They're much happier. Alright, so write this down now. What? Okay. States of matter.
States of matter.
Stars of
Got this? Yeah. Okay. Right. So there's not the two. We can get 2 lessons done because there's not a lot in each lesson. So, states of matter. Now I don't need to talk much about this because you know, as being chemistry students, that water, when you look at it at an atomic scale, a 10 to the minus 10 scale, it's actually a collection of little particles, little molecules. In fact, you should all already know what water is made of from middle school. Like, what is water? It's 2 hydrogen and an oxygen bound together. So in other words, liquids and gases are actually like little balls all together. And you know this from science. Things are made of atoms. But more importantly, these atoms come together to form molecules. So a molecule is an electrically neutral, no-charge group of 2 or more atoms held together by chemical bonds. So an example of a molecule is water, which is H2O, 2 hydrogen atoms bonded to 1 oxygen atom. And molecules are kind of more important than atoms because molecules are what make up the material. Yeah.
What's the
Clump. Oh my goodness, what's another word for clump? Glob. The definition at least, yeah. No, clump. Glob. Blob. KJ, help us out here. Another word for clump or glob or blob. Clump. Anybody? Clump, glob, blob. You see, we can't explain it. It's a thing.
Mixed together.
Yeah. I'm sorry, Tekken, you might have to look this up in the Korean dictionary. I have no other word for clump. Clump, C-L-U-M-P. Blob is no good for you, is it? Blob, you know blob? No. Glob? No. Did you get clump there, Claire?
Yeah, but it's weird. Some plants.
Huh?
Some plants together.
Plants? No. You'll have to check it later. I have no more synonyms for
Clump
clump.
of trees.
Yeah.
Cluster.
Cluster, yeah. Anyways, did you write this definition down? No.
Group of 2 or more.
In fact, we'll talk more about atoms. Yeah, but it's not quite globby enough. It's like porridge. Ticket. No. There's a fancy word. I guess so. Ticket, yeah. But ticket's kind of used for plants, isn't it? Anyways, we'll talk more about atoms later in the semester. That's not really for discussion right now.
Okay.
Yep. Alright. So what does water look like at this molecular level when it is frozen solid as ice? So when water is frozen solid or ice, or what does it look like when it's a liquid? Or even what does it look like when it's a gas? So they'll look different when it's a solid, liquid or gas. So what you have here in the picture is, this is water when it's an ice. The molecules are quite tightly packed together and they're not really free to move, but they can vibrate. When it's a water, a liquid, they're very close together and they're quite free to move. But when they are a vapor, when they are gas as steam, they're quite free and they're not close together and they're very free to move. As you know from English, when it goes from an ice to water, we call that melting. When it goes from a water to steam, that's called evaporation. When it goes from steam back to water, that's called condensation. And when it goes from liquid water to solid ice, that's called freezing. In fact, you can have situations where it goes from a solid, skips being a liquid and goes straight to a gas. Does anyone know what that's called? Solid, straight to gas, skipping liquid. Sublimation. Good job. And then the reverse, there's another one called something, I don't remember, deposition. When it goes the reverse, I think. Gas to it. Anyways, the vocabulary here is important. Can you see the picture okay? So you need the, if you could try and draw this. Yes, actually, if you could try and draw this would be great. In the exam, they could ask... No, I don't even know. Yes, is that gas to solid, skipping liquid?
Yeah, it's deposition.
Deposition, yeah.
What can I ask in the exam?
In the exam, they could ask you to explain the difference between the three states of matter. The picture will help you remember.
Spelling of
It's a bit small, isn't it? I'm sorry, I should make the picture bigger. Condensation, C-O-N, con, D-E-N, and then S-A-T-I-O-N. And that last one is freezing. What you doing on your phone? Now put the phone in your pocket. I think it's starting to distract you too much.
What was the
What?
ice to gas?
Oh my goodness, ice to gas. Oh, sorry, solid to gas is called sublimation. Yeah, and then if you jump from gas to solid and skip liquid, that's called deposition. Okay, can I go on?
Yeah.
By the way, how do you change a solid into a liquid?
Solid into liquid?
Yeah, how do you make a solid into a liquid?
Heat.
You heat it, you give it heat energy. And then to go from a solid to a gas, more heat energy. How do you go from a gas to a solid? Yeah, but how?
Gas to solid pressure.
Yeah. You remove heat energy, which is what a fridge does. And then to go from a liquid to a solid, you remove more heat energy. So what is a solid exactly? So we call something a solid if the atoms are fixed together. Wait, now before you write it down, at least hear it. A solid, the position of atoms are fixed relative to each other over a long time. So in other words, they don't really move. And this is due to friction between them, or cohesion between the molecules. This cohesion is provided by metallic, covalent, or ionic bonds. So in other words, they're held together by these types of bonds. Now, as physics students for the exam, we don't even need to know that. But because you're chemistry students as well, I thought I'd put that in. Only solids can be pushed by a force without changing the shape. So if you push a liquid or a gas, you change its shape. But if you put a solid, you don't. which means they can be resistant to deformation. That means changing of their shape. Solids also...
This is a solid.
Yeah, no. You could still push... Yeah, okay, look. All solids can eventually be broken if you give it enough force. Yeah. And anyways, hang on, KJ. I didn't say it was perfectly impervious to change it. They just said it's resistant, which means it will try to fight back. Look, it defied you and went back to its original shape, okay? Solids also tend to be strong enough to hold their own shape in a container, and solids are generally denser than liquids. Solid becoming a gas is called sublimation. Now, wait. Don't be ridiculous and write the whole thing. Alright? You need to write what is the most important point. What's the most important point here?
Solid becoming gas is sublimation.
Oh my goodness, that is like so not the most important point.
Postulates.
Yeah, really that the atoms are fixed to each other, and the fixing is provided by a friction force, which is a kind of metallic covalent or ionic bond. Oh, dude, would you chill out?
Stephen.
Oh no, write the first two sentences would do. Man, I
That should be
am
chemistry
hungry. What?
Should be in chemistry class.
You will do it in chemistry, don't you do it in chemistry?
Yes, sir. That's why I didn't hear.
Deal with it.
Have you ever been in Cork?
Yes. Did you go to the Cork talk?
Yeah.
Yeah.
This town sounds good actually. Town sounds good.
Cork is a good university, and the town is good too.
It's cheaper, is you would say.
Yeah. Well, anywhere's going to be cheaper than Dublin.
Anyway, it's cheaper than Dublin.
In Ireland, at least.
So why that come to Dublin?
Yeah, I don't know. Why did you? Because you heard about me being here.
The Happenstein student was saying before coming here, they were told that they have many options.
Who was on this?
Like Happenstein students.
Yes.
But when they came here, they said you only have 7 options for medicine.
I guess it's just a choice of English. I would consider, for medicine, yeah, I consider 7 options a lot. Many options. Because, for example, some foundations, like for example, if you go to Tralee Foundation Programme, you can only go to, I think, RCSI. Or if you go to...
But that's guaranteed if you pass the exam.
Of course, but that's true about anything. If you all get the grades you need,
If they even they got A stars, A's, they're not sure if they get the position in RCS.
for RCSI,
Yeah.
but then there's 6 other places.
And 2 the main, one in London,
Shannon?
yeah, something like
No, the one in London is St. George's.
Yeah,
Oh,
same
yeah,
size, yeah.
yeah.
They're not confirmed by them. And the rest is like nothing. They don't.
Yeah, but I think, now I've been here 8 years, and I can tell you that if you get top grades, sure the place is not guaranteed, but I don't ever remember an international, a non-European student getting A's and not getting RCSI. No, that's never happened. Now, they're not going to guarantee your place, they're not going to give you an offer letter, but I've never seen it happen, that if you get A's, you don't get RCSI. I've not seen that happen. So, it's not guaranteed, but I think they just say it's not guaranteed to keep their options open in case they decide, oh, wait a second, this student got A's, but they're a bit of a weirdo. You know what I mean? Because you have to do an interview as well.
Yeah.
So you could get A's, but you could be a weirdo and they might decide, no thanks, actually, you go somewhere else. I think this is the real reason they say it. Whereas if you're doing engineer, you can be the weirdest person ever, and they'll still welcome you. Yeah. All right. Good news for this class.
You don't
Okay.
have to interview.
Huh?
You don't
No,
have to.
exactly. You could be a complete weirdo. It is okay. All right. A liquid. So what do you think makes a liquid different? Well, it's that the atoms are more free to move. So molecules... actually, KJ, can you get the light? It's a little bit hard to see. Yeah, go on. Yeah. Oh, yeah. Do it. No, leave it. It's actually... No, leave it. It's fine.
No, that's fine.
In a liquid, molecules are attracted to other molecules strong enough to keep molecules in contact, but not strong... Actually, put her back on. It's a bit dark. But not strong enough to fix the shape. So the force is strong enough to keep them touching, but not strong enough to keep them in one place. The molecules are always moving. This means a liquid can flow smoothly, but not as smoothly as a gas. Liquids will take the shape of the container they're in, but they're generally less dense than solids, but denser than gas. So again, you can just write down the first 2 sentences will do the job.
Liquid.
Yeah. You going to watch Flash tonight?
Yes. I finish assignments on time.
That can be your treat to yourself. Yeah? Got my homework done, time to watch Flash. And Arrow as well.
You should tell us the deadline, so we'll be.
I told you, it's like 2 weeks after the... 2 weeks after the time that we did the labs. We did the labs a week ago, didn't we?
Yes.
Yeah, so like it's not too far away. But look, the thing is, once you show me the draft next week, then you can finish it like in a night or two, because I just need to have a look at it and say, okay, good, bad, change, fix.
What do you want to say?
I wrote the draft in
Next
pen.
week.
I wrote the draft in pencil.
That's fine, because it's the draft. I don't care about the draft. I just want to see what you write so I can say yes, no. Or in some cases, no.
In some cases, yes.
Maybe. Right, have you got this? Right, finally a gas. So with a gas, they're not strong enough to hold the atoms together. Basically the molecules move quite freely and independently of each other. They're unbounded, and their main interaction is just collision. Gases tend to take the shape of the container they're in. They're less dense than both solids and liquids. Yeah. The key thing again is the first sentence. First sentence.
From this a gas.
And from this, a gas is a collection of independent, unbounded molecules which interact mainly by collision. got it? Can I go on? Yeah. Yes. Okay. So this is just, you don't even have to write this down. It's almost like a silly question. You put some ice on a table. Describe how the ice changes over time. So originally the ice is in what form? Solid. As it gets more heat energy, the molecules become freer until it becomes a liquid when the molecules are moving around more. So what's happening, look, when it's in ice, the molecules are quite tightly stuck together. Then as it gets more heat energy, it starts to free up until it starts to move around. But they're still touching. Okay. Molecules are still touching. Yeah. Then as it gets more heat energy, it'll start to become free. So then the molecules are moving around and their only interaction is when they collide. But they're not touching anymore. That's when it becomes a gas. Okay. Right, so there's a few questions. There's no calculations in this, and a couple of things you have to look up on Google. So if you want to take a picture of that, we'll start the next lesson then.
Will upload in the world?
Probably not, because I'll be going straight home after this. KJ, the camera's pointing the wrong way. You're taking a selfie.
So do you need to answer them?
You do, because it's interesting.
This is like not a calculation question.
No, there's no calculations in it.
Questions, but
Yes.
we are engineers.
Yeah, well, look. Of all the lessons I've given you, only 2 lessons have no calculations in them. This one and then the lesson on conservation of energy. But that's it. So quit complaining. Right?
So calculation, you feel you do something.
Yeah. Well, don't worry. There's the next
You
lesson.
feel
Okay.
like you're an engineer.
Yes.